Hello, this is Ian Harper welcoming you to Business of Weather podcast, produced in association with Asia Climate Forum, Asia's largest event dedicated to extreme weather and climate change, flooding and poor air quality. In each episode, we'll investigate the increasing impact of extreme weather and climate change on business and society, and look at how weather technology and climate information services can help address the growing challenges. We'll also spotlight the new opportunities for entrepreneurs and business startups seeking to develop the business potential of technology innovations to help those affected by extreme weather.
It's Snoop Doggy Dogger, Fisher, German Bight, Humber, Thames, Dover, White, Portland.
The University Corporation for Atmospheric Research, or UCAR for short, is a US non-profit consortium of more than 115 North American colleges and universities focused on research and training in the atmospheric and related sciences. Since its formation in 1958, its aim has been to share ideas, discuss challenges, and share knowledge. Through cooperation with the private sector, it takes research out of the lab and into the real world for the benefit of society. UCAR has a major presence in the community, which embraces numerous areas ranging from encouraging diverse students to pursue science careers, to providing online professional training, data delivery, and other services. UCAR also manages the National Centre for Atmospheric Research, or NCAR, which is set up in partnership with the US National Science Foundation to address pressing scientific and societal needs involving the atmosphere and its interactions with the oceans, land, and the sun, what is now called Earth System Science. To get an inside view on UCAR and how it is responding to the growing challenges of extreme weather and climate change, Business of Weather spoke to the UCAR president, Dr. Tony Busalacchi. Welcome to Business of Weather.
Thank you, Ian. I'm pleased to speak with you.
Now, can you tell us a little bit about UCAR, its work, and how you are funded?
Yes, so UCAR is the University Corporation for Atmospheric Research. We've been in existence going back to late 1950s, and we are a not-for-profit organization consisting of 120 member universities across North America. And we also manage the National Center for Atmospheric Research, which is a federally funded research and development center, which is called an FFRDC. And it's the National Science Foundation here in the United States, their oldest and largest FFRDC. So you may be familiar with the Jet Propulsion Lab, which is managed by Caltech. So JPL is an FFRDC for NASA, NCAR is an FFRDC for NSF, and JPL is managed by Caltech, NCAR is managed by UCAR. And then in addition, we have another part of the organization called our University Center for Partners, our UCP group. And we also get money in addition from NSF, from NOAA, and NASA, and other agencies as well.
Now, since UCAR was established in 1959, what would you say are its most notable achievements?
Well, that's a tough question going back so many decades, but let me go sort of some sense of top 10 or so. We've recently been involved in running a program in GPS meteorology, the COSMIC program, that has been joint with Taiwan, U.S. Air Force, NSF, NOAA. It's a series of radio occultation satellites that are essentially doing like a CAT scan of the temperature and humidity of the Earth's atmosphere as a result of the delay of the GPS signal as it goes through the limb of the atmosphere. And that's now, we just launched the Cosmic 2 in mid of last year, and that is now proving to have some very important information for the prediction of tropical cyclones. A lot of work going all the way from basic research to applied research. We're doing renewable energy forecasts out of our research applications lab at NCAR here in Colorado. Xcel Energy is the main energy company in the Front Range of the Rockies, and we've been able to save the ratepayers approximately $10 million a year in savings as a result of accurate renewable energy forecasts. We've also developed technologies going back several decades that detect low-level wind shear and provide alerts at the nation's airports that mitigate the effects of violent downbursts when planes are taking off and landing. Oh, let's see. We also have developed out of our regional weather forecast model, the WRF hydrology version of WRF Hydro. That model has provided the basis for our national hydrological model being run by NOAA, the National Water Model at NOAA's National Water Center in Tuscaloosa, Alabama. We invented a dropson technology that's been licensed to Vysala, that's been shown to improve the track of hurricane forecasts for landfall anywhere from 15 to 20%. On the science side, scientists at NCAR in the 1970s discovered the Madden and Julian oscillation. We were responsible for developing one of the first atmospheric general circulation models under the leadership of Warren Washington in the 1960s, and still to this day, the NCAR model is one of the United States main models that go into the CMIP into comparisons for coupled climate models that are assessed by the IPCC. And then we also have a very strong program called SOARS that provides opportunities for underrepresented minorities in the atmospheric sciences. And so that's just a list of some of the highlights over the past several decades.
Quite an impressive list of achievements there. Now, does UCAR work exclusively with US universities and organizations, or does it also work with those in other countries?
More of the latter. It's a combination of both. As I mentioned, UCAR is a member of 120 member universities. 115 are in the US and 5 in Canada, namely McGill, York, University of Toronto, University of Saskatchewan, and University of British Columbia. We also then have 60 international affiliates in every continent except, of course, Antarctica. We also have arrangements with private sector organizations. Skymet is the largest private sector weather provider in the country of India. So a combination of universities, private sectors in the United States and across the world.
Now, how important is cooperation between the public, private and academic sectors to furthering atmospheric research and then applying it to help address the growing challenges of extreme weather and climate change?
I like to liken the weather enterprise as a three-legged stool. Three-legged stool across public, private, and the research academic sectors. And a good example of this is what I saw was I moved to UCAR in 2016. And prior to that, I had been at the University of Maryland in College Park, Maryland for 16 years. And while there, I saw firsthand the value of the government, public, and research sectors. I had been a civil servant at NASA for 18 years, while at the University of Maryland, we had cooperative agreements with NASA and NOAA. But then I also saw when Neil Jacobs, the acting administrator of NOAA, was at Panasonic, he was providing funding to graduate students at the University of Maryland for data assimilation and taking aircraft data and really accelerating research to operations. And so these students got exposed to the rapid refresh cycle of the private sector, got access to much greater high-performance computing that they could get elsewhere. And that student, she or he, had a job opportunity waiting for them should they want to once they graduated. And so that's a great example. At UCAR and NCAR today, we have partnerships with IBM, the AER Corporation, Vysala, I already mentioned. In terms of, we talk a lot in our field about research to operations. I also like to talk about R2I, research to industry, in terms of what we can be doing to support the private sector.
Right, now coming bang up to the present day, speaking as the head of a leading atmospheric research agency, what do you think the public, private and academic members of what we might call the global weather enterprise can do to help consolidate and extend the benefits of reduced carbon and other emissions gained during the COVID-19 lockdown?
That's a great question, Ian. And we're in the midst of a natural laboratory right now with COVID and the reductions in the output of greenhouse gases. We had previously a very smaller version of this post 9/11 in this country. But at present, a team of NCAR climate and atmospheric chemistry experts are analyzing the impacts of reduced emissions in Asia, Europe, North America. And this will allow us to reassess sort of the scientific baseline for policy. And then, how the atmosphere sort of responds to this. Those data are going to be incorporated into our models. And so, it'll teach us, how the atmosphere and the Earth system is responding to this hiatus. I think it's going to tell us more about climate sensitivity in our climate models. It'll also provide us input into the whole area of geoengineering. And ethics aside, there are still some fundamental basic science questions that need to be answered with respect to, can we overtly be managing the Earth climate, and what are some of the unintended consequences of doing such?
Now, a lot has been said about the link between air quality and health, and how poor air quality may have worsened the impact of the COVID-19 pandemic. Do you see health aspects of atmospheric research growing in importance?
Yes, I do, in short. The importance of air quality research has long been recognized and has helped to inform policy decisions for decades. And at UCAR and our UCAR community programs, we're going to continue to do research into air quality. In the last year, as just an example, our scientists have helped to provide India with 72-hour air quality forecasts and doing similar work in the United States. But then beyond just air quality, there's the whole link between weather, water, climate, and disease vectors, such as Zika. We have a program in our GLOBE program with NASA, but a particular part of that is being funded by the State Department, looking at Zika spread. We also have the vector-borne diseases related to precipitation, such as malaria and dengue. And then going back to air quality, the link between PM 2.5, cardiopulmonary disease, and asthmatic diseases.
Now, just staying with COVID-19 for a minute, your partner organisation, the National Centre for Atmospheric Research, or NCAR, has joined the COVID-19 High Performance Computing Consortium by providing one of the world's top supercomputers to help research the COVID-19 pandemic. Can you explain what this is about?
Yes, Ian. This is just beginning. It's very exciting for us to be able to contribute to the national and international need. Our Cheyenne supercomputer in Wyoming is a 5.3 petaflop machine, and right now that ranks about amongst the 50 fastest high-performance computers in the world. And so as part of the consortium, this machine is being made available to scientists across the country for research into such questions as transmission patterns and seasonal influences on the virus. And so at a high level, advanced supercomputing is vital for accelerating our understanding of the virus and better protecting society during this pandemic. And this is another important example of this partnership across government agencies, the private sector, and academia all working together.
You're listening to Business of Weather, produced in association with Asia Climate Forum. Moving on, let's take a look at the science and technology aspects of your work. What science and technology innovations are in the pipeline which you believe will be especially useful to your work and its applications in the coming years?
So I briefly mentioned some of the partnerships, and I'll go into a little bit more detail here. We have a partnership with AER Corporation in Cambridge related to the Cosmic Radio Occultation Program, where we've licensed some of our processing software to AER, and they will be doing the processing for a lot of the commercial satellite vendors that are out there. And I'm very bullish on the prospect of the private sector in the ability to provide some of our meteorological data going forward. We have a very vigorous partnership with IBM, where our next atmospheric model going into the future is called MPAS, Modeling for Prediction Across Scales. And in our partnership with IBM, IBM is porting this predictive platform to graphical processing units, GPUs, to accelerate the compute time, reduce the compute time, but accelerate the efficiency on these platforms. And it's a win-win because we get to make the benefit of the IBM experience in software engineering and then turning it around and make that available to the research community. There's another area in our Earth Observation Lab at NCAR. They've proposed to the National Science Foundation a next generation airborne phased array radar, APAR, that would be sitting on our C-130, our NSF's C-130 airplane that we manage for the National Science Foundation. And this will allow us to peer into the development of severe storms without having to penetrate severe storms and endanger the health and safety of the pilot and the crew, and look at the microphysics of clouds and cloud condensation nuclei and how severe storms generate, but do that from afar without having to penetrate. So it's an exciting new technology for us. And if that proves successful, it's also an observational platform that we might be able to port over to NOAA in a operational research to operations for observations. We oftentimes talk about R2O for modeling. This would be an R2O example for observations. And we are very appreciative of the money that we've received to date from NOAA that has bought down the risk for this new technology so that we can propose it to the National Science Foundation.
Now tell me, how good do you think weather forecasting can get? Can a single weather model be run globally at a resolution high enough to resolve individual thunderstorms? If so, then how can such a powerful forecasting capability be used by business and society?
It's a great question, but it's not a question of if or when. It is actually happening now. And it is a result of this partnership with IBM. I mentioned our model, the NCAR model, MPAS, has been ported over to IBM, and their new prediction platform built around MPAS is called Graph. They are now running that model at 3 kilometers. And so that means, an average thunderstorm is about 24 kilometers. So they are explicitly resolving thunderstorms. So in the past, numerical weather prediction models of tens of kilometers resolution, there was a need for convective parameterizations to parameterize, let's say, severe updrafts and thunderstorms. Now they are no longer in this IBM platform, no longer have the need for convective parameterizations because they're explicitly resolving. That model has only gone operational recently, but that the future is now in that regard to your question.
Okay, now UCAR has strong community outreach programs, I believe. Can you tell me more about this?
So as I mentioned, we have 120 member universities, and one of the raison d'etres of our organization is to support the community. And so we've talked about the Cheyenne supercomputer, which supports the National Science Foundation research in atmospheric sciences across the United States university community. I mentioned our Earth Observation Lab and the C-130 platform from NSF. We also have a Gulfstream 5 aircraft. So one aircraft flies low and slow, one aircraft flies high and fast. And these are platforms for the university community for field programs, process studies. In addition, one of the things we're known for is our approach to community models. So I mentioned the weather research forecast model, but our coupled climate model is the community Earth system model, and that provides a basis for our climate change projections. But as mentioned, it is a community model. So different parts of the model are being looked at, different parameterizations are being actually developed in academia and then ported into NCAR. So, our whole reason for being, once again, is collaborating and supporting the university community.
Right, let's just gaze into the crystal ball. How do you see the future evolution of UCAR? What are the major challenges that lie ahead?
I would say that our future is moving in the direction of Earth system science. And if we kind of go way back to how UCAR and NCAR started, this had its genesis back in the 1950s. Coming out of World War II, our knowledge of the physics and the dynamics of the atmosphere were such that when we had the advent of digital computing in the 1950s, some of the founding fathers of our field, and they were all male at that time, unfortunately, saw the need for a national center to accelerate progress and understanding and predicting the atmosphere. And as a result of that, in the United States, we've had a growth of the private sector weather enterprise, where today it's a multi-billion-dollar enterprise. That's a grand success. But that led to the formation of NCAR in around 1959 and 1960, the National Center for Atmospheric Research. But if we fast forward to today, there is not a National Center for Oceanographic Research, a National Center for Hydrologic Research, the National Center for Cryospheric Research. And if there was a proposal for a National Center for Atmospheric Research today, probably be dead on arrival. Yet the arguments that led to the National Center for Atmospheric Research 60 years are just as valid, if not more so today, with respect to predicting the Earth as a coupled system. And so if I gaze into the crystal ball over the next couple decades, I see a tremendous outgrowth in actionable predictions in support of a whole range of societal benefit areas related to the Earth as a coupled system. Agriculture, riparian zones, the built environment. We talked about disease vectors, solar storms. I think that's where our future is. And for us, I think it's a very exciting time to be at this juncture in the history of our science.
Well, that concludes today's interview. Dr. Tony Busalacchi, President of the University Corporation for Atmospheric Research, thank you very much.
Thank you in return, Ian. It was indeed a pleasure to speak with you today.
You're listening to Business of Weather, produced in association with Asia Climate Forum, Asia's largest event dedicated to addressing climate change, flooding, and poor air quality.